Hello, good morning from California. Hope you're all doing well. This is Dr. Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. This is video number 6 for user-defined function in C. And in this one, we are going to talk about mutation and populating values in the calling block. Functions can be used to change values, which is called mutation in computer science. Or if there was no value to begin with, populate the values in the calling block. And this is very useful at times. So what is mutation? This is a new word I introduced, so I should talk about that. Mutation of data or objects is a very important concept in computer science as it relates to changing the state of the object. An object should always be in uncorrupted state. And once you change it, the change state should also be uncorrupted. So mutation should create uncorrupted objects. Example of a corrupt versus uncorrupt object is, let's take example of bank account object. It has balance inside it. So valid state of a bank account object will be that balance is 0 or higher on the positive side. As soon as balance becomes negative, unless overdraft is allowed, it has become a corrupt object. So any mutation of balance in a bank account should be such that it conforms to business rules so that it never becomes negative. Mutation should be such that it doesn't create corrupt objects. We will not talk about how to prevent corrupt mutation now. That's a topic for other courses, but just wanted to say what that is. There are times when lack of mutation or immutability is also preferred. For example, when you choose a username and password in an internet account or in a local area network, that string should not change. In those situations, lack of mutation or immutability is preferred. So mutation is changing the state of an object. For simple variables, mutation means changing their value from current to a new value. Okay. So user-defined functions can be used to cause data mutation in the calling block. And the way it works is that when a pointer to an object is passed to a user-defined function, and you already know from the pointer technology, the function has the access to the memory location of that object. Since it has access to the memory location, it can cause mutation of the value stored at that memory location whose pointer is passed to the function. At times, such mutation is a very useful part of algorithm. And one such algorithm is bubble sort, to sort an array in ascending or descending order. And we're going to demo bubble sort just briefly, that what is the bubble sort and why data mutation is required in it. And we show an online demonstration of bubble sort to see what kind of data mutation is needed. And that mutation can be done by user-defined function. And later on, we'll write such a function that includes swapping data into memory location. So give me a second. It's going to take a little bit of a time to find that demo, but we'll do it. So Harvard, okay, University X sort lab, yeah. And if you need to know this website, I will copy and paste that into a Word document so that you can see it, and you can pause the video and note down this address. Okay, that's too big. So pause the video to note down this address. Okay. I'll just minimize it. Okay, so imagine that height of bars here represent values stored in an array. Array is a collection of elements where values are stored contiguously. We'll do a lot of work on arrays a little bit later. So notice this, actually I do want to make it a little bit different. Let me see. Okay, do I still like it? There's a reason. Okay. Okay, yeah, this is a little better. Okay, but I want to make it bubble sort. Okay. So can you see this value is larger than this one? This is smaller than that. This is smaller than that. So if this array was sorted, smallest value will be in the slot number 1, and the largest value will be in the slot number 16. And if you can visually see it, this should be here, and this seems like largest value should be here. So how does this algorithm works? So it's going to compare 1 and 2, and since 1 is larger than 2, and 2 should be before, this one should be before that, so they should be swapped. And that's how the animation works. It's going to compare these pink circled bordered values, and it knows this is larger than that, so it should just swap them, and it does. Now it compares these two, but these are in the right order. This should be, this is smaller than that, so there's no need to swap here. So it moves on. These are in the right order, no need to swap here. But these two are in the wrong order. This should be before that, so they are swapped. So keyword here is the swap. We are swapping the data. These are in the wrong order too, so these two will be swapped. And now it seems like I found the largest in the array, so there will be swapping going on until all the way until this bubbles to the end. So swapping here, these two will be swapped, these two will be swapped. This is larger, smaller, swapped again. Larger, smaller, swapped again. And I will let it run now, and you can just watch that they're being swapped. Swapping, 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 swapping. And there is a reason why this became dark. Largest value is here, so I don't need to look at this anymore. Next time I only need to run from here to here. This is already sorted. So just to show you that this does sort, I'm just gonna run it, and I'm gonna do it very fast now. Yeah, there you go. In each run, largest value in the unsorted array will be bubbled to the end. So these three got sorted. This is unsorted. So in each run, unsorted array decreases by 1, sorted array increases by 1. By the way, I have bubble sort video showing this separately as well. Just go to my channel and type single bubble sort and you will see it. Or just go to YouTube and you will see it. Okay, got sorted. So you saw that swapping data took place when if one element was ahead of the other one. We can show once more by reloading it. So like this is larger than that, then swapping will take place. So swapping data of two memory locations, it's a very, very important activity in computer science. Happens in sorting all the time. When a function is used for that purpose, those two memory locations will be passed to the function, and then function can swap the data. Okay? Now, what we're going to do is, we saw why swapping is important. We're going to show you now in compiler Xcode two swap functions, one that does not work, another that does work, and we'll explain why each one behaves the way it does. Okay, so let's start our Xcode now. And bear with me because I need to create a new project. Should have done it before video started, but forgot to do that. Okay. Okay, just to keep life simple, I always kind of give you a simpler version of main, which is this one. So you saw that when swapping was done, one of the variable was saved in a temporary location, then copy was made into other one, and so on. But simple function will be this: void swap one, and it's going to take, we'll just take integers, keeps life simple. Int left, okay, or let's say val1, int val2. That's a prototype. I said prototypes are always required. You cannot renege on them. So what is the swapping mechanism? I want to make sure that after function finishes, val1 has the value that was in val2 and vice versa. So I'm going to create int buffer, a temporary buffer. In that I'm going to say val1. Okay, so since val1 is already saved, I can copy val2 into val1. So I can do this, equal to val1. This is my first swap. And I've saved into buffer the val1, so I can say, no, I'm sorry, the other way around. I've saved val1. Okay. And then I can say val2 equal to buffer. That's the swapping mechanism. Now, we don't need to even print these to make sure the swap did work. We can see it in the code. And now I'm going to declare two values here and then call the swap1, print the values before and after. So let's create two of those. Int data1, int data2, and just to contrast, I'll create values negative and positive. Data1 is, let's say, -5, data2 is 10. They couldn't be farther apart. Print them before calling the swap1. Print before calling swap1 data1 equals %d/n 1. So I print one of them, and then I should print the other one, data2 also. Data2 is data2. Now we're calling swap1 to swap them in the calling block. That's of course our purpose. If it doesn't change here, my sorting the array is not going to work. And then after calling swap1, I want to see, did they actually swap in the calling block, which is main function. So I just say after calling. Okay, let's run this program. All right. And now I can show you. Before calling the swap1, data1 is -5, data2 is -10. After calling swap1, data1 is -5, data2 is 10. No change. Our swap failed in the calling block. But you can see swap was done here. You can clearly see that val1 was set to value of 2. Val2 was set to buffer, which was val1. But no swap happened in the calling block. So it's a bit shocking what happened. We need to go back to the mechanism of data transfer when values are passed. So when this swap1 is called, copy of data1 is made into val1. Just the copy of data2 is made into val2. And they do swap. But since swap1 has no hold on the memory address of data1 and data2, this local swap did not affect the value of data1 and data2, because all val1 and val2 are simply a copy of data1 and data2. That's pass by value mechanism or pass by copy mechanism. Okay, a lot of new programming students don't understand. Until we show them this, they don't quite understand pass by value mechanism. Only copies made. So swap1 cannot cause the mutation in the calling block or in the main function, because if you are mutating a copy, you're not going to affect the originals. You're only mutating a copy, not the originals. So originals will remain unchanged. Okay, so that's not going to help us in the bubble sort. Okay, if we send two memory locations, as we need in bubble sort, that's not going to help us. So what we need to do, in order to call the mutation in the calling block in the main function, we need to pass data1 and data2 pointers to them, and that's when successful mutation will take place. So I will write this other function, swap2. This time we're going to pass the pointer to 2 memory location, not the pass by value. Int val ptr, let's say val1 ptr, and int asterisk val2 ptr. Okay, so this time we're going to pass the pointers and then see whether mutation occurred or not. So this one doesn't work. Let's try this one. Okay, this time we're passing a pointer, and again, I want to make sure that you understand that prototype and these names can be different. So I'm going to change it here, IPTR, make it IPTR, IPTR1 and IPTR2. Yeah, I want to emphasize that name here and name here doesn't have to be same. In fact, you can skip the name there. Usually I don't, because those are needed for documentation. But name here, here, here can all be different. Okay, so we got the pointers passed to swap2. Now, in order to get a value of the pointee through the pointer, you know what we need is the dereference value of the pointer. So we'll save the pointee of this one, which is dereference IP, what I'm doing, IPTR1. So buffer now saves the value of pointee of this pointer. Okay. Meaning of dereferencing is go to the address stored in this pointer, grab that value, and in this case it will be stored in the buffer. Since we saved first value, now in order to change the value in the pointee of this one, we just say dereference value of IPTR2 equals no, once again I'm making that same error I made before, 1 equal to dereference value of IPTR2. So meaning of that is that whatever was stored at the pointee of this pointer, change that, get the value of the pointee of this pointer. So we did our first swap. This is swap number 1. And then memory location pointed to by IPTR1 was saved in the buffer. So then we can say dereference value of IPTR2 equal to buffer. So once again, this swap has taken place locally. We can clearly see that because we are saving memory location 1 in the buffer. Then in that memory location 1, we are copying value of the at the memory location 2, and at the 2 we are swapping the buffer, which was at the 1. So this is swap number 2. Now this time we can see, of course, locally there is a change. but we haven't called this yet. We'll call that here. Did it take place? Swapping takes place in the local calling block also. So we'll call the swap2 now. And this time we call, since it is expecting pointers, we'll pass the memory location by the address data1, comma, address of data2. When pointers are being passed, memory location are the actual argument. And now we can see that did it swap here. So this will be after calling the swap2. Okay. So this will run, but I want to run it in a terminal so that I can see it is a bit more clear. Okay, so let's run it. Succeeded. Get the products. Make it a little bigger. Okay, so up to here we have seen that swap1 didn't change anything, but can you see here, after calling swap2, data1 is 10, data2 is -5. And if this font is small, I don't know, I can copy and paste that bigger. Command plus. You can see that after calling swap2, the exchange of data did take place. So mutation in both memory location has been done by the swap2 function. Anytime you want to change, cause mutation in the data in the memory block passed to the function, it has to be passed by pointer. Pass by value, no mutation in the calling block. Pass by pointer, mutation in the calling block. Okay, so the reason that happens is that this mutation takes place is that when you're calling the swap2, memory location at this pointer and this pointer got shared. It's a shared memory in the both functions. We're passing the memory of address of data1 and data2, which is stored in the pointer val1 ptr, val2 ptr. Those memory location gets shared. Shared memory location between two functions. When that happens, the actual value at that memory location can be altered by the function that has been called. So another technology I want to point out here is that you can see here both this function has an input value, ingoing value and outgoing. So it might help you a little bit that if you take some comments and just write down something like this, ingoing and outgoing, both values. There are ingoing value and there is outgoing value for both parameters. And here also there is ingoing and outgoing. You just have to do this in prototype to clarify that there is an ingoing and outgoing value. When you write your functions, data passed by pointers, there's ingoing and outgoing. But I want to show another example where function may be getting a pointer to a memory location which doesn't really have anything. Okay, so ingoing, there's no significant value or no value at all. Outgoing, we want it to do something. That situation happens when function takes some data input from the user, but instead of just returning one value, it is supposed to pass another value to the calling block as an example of data input. So I'm going to rename it main1 and just kind of go here somewhere and show you that. So imagine I want to write a function which is called to get age in years and GPA of a student. So we'll call it age could be int get age and GPA. So age on last birthday will be whole number, so I can return that by return mechanism. But since function can only return one value, second one I have to return through the pointer. So here I will say double pointer GP. Okay, and I'm just gonna write my int main here. This is my second program in the same file. Okay, so how would this get age and GPA work? This is how it's gonna work. We'll prompt user for age on the last birthday. So we'll say int age double GPA printf enter age on last birthday, which will be a whole number. I'll do scanf %d. Okay, so string address of age. So we got our first input. Then we need the GPA. For GPA, of course, there is a pointer here. So pointer already has the address. When I pass to scanf, I don't need to do anything. Just provide this address. Okay. So enter current GPA. Could be 0. And in this case, this will be %lf. And it's already a pointer, so I just need to give pointer name. And once again, I want to be careful that, okay, that you're not confused that this name and this name has to be same. So I'm going to change it. Current GP. Okay. Now age was a local variable, and we're going to return that by return age. But notice that when a variable in the main function pointed to that is passed, the current GPA got changed here, so that change value will be passed to the main. So in this case, GPA incoming didn't have a value, so it has only outgoing value. Incoming value will inconsequential, insignificant, so it has only outgoing. Okay, now we're gonna just call them and print them in the main function. So here I have int age on last BD means birthday, double GPA current SEM, current semester. Okay, now I'm going to pass this, use this function. So I'll say this is by the return mechanism equals get age and GPA, and pass to this address of this because there's a pointer being passed here. So address of this. So now take a look. Address being passed, that means that is address stored in this pointer, and then this pointer's pointee is being populated here by the scanf. Okay. We don't need to put a ampersand sign here because this is already a pointer. Now we can print both results. Printf age on last birthday %d years and this is the one. Current GPA. If you want to print it to 2 decimal place, 2 LF slash n. Okay, let's review just a second. The function is affecting two values in the calling block. One is age on last birthday. That's being, okay, this is a mistake here. Why do I even need this? I don't need this actually. I can delete that. One age is being returned by the normal return mechanism. But the second one, a mutation is being caused in this variable whose address is being passed, address stored in this pointer, and then it's being filled with the user data here. It's almost like as a function returning two values. So this is what happened when you want to return more than one value, although return is not the correct word for it. One can be returned by return mechanism. All others can be mutated. Variables can be mutated and given new value. And in this case, okay, this might be outgoing has no value, so this must be actually ingoing. Yeah, outgoing is the only one that has value. Incoming has no significance. Okay. So in this case, outgoing is the one outgoing from the function that has some value that is significant. Ingoing has no value. In case of swap, we had both. Ingoing and outgoing had some significant values. In this case, only outgoing. Okay, let's run this one. And my terminal already has that, so I can do that in terminal as well. Just do that. Age on last birthday. Hey, I'm old. I'm going to put 55. GPA 3.9. And age on last birthday is 55 years. Current GPA 3.9, which means that this function was able to mutate one value, mutate the value of this one, and return a value stored in this variable. And then we were able to, in effect, we are able to return two values, not one, but two. Although return is not a good name when we call the mutation in the pointy of GPA. Okay, so when you pass by pointer, you can cause the mutation in the memory location in the calling block, and there are two mechanisms for that. Like in swap function, swap2, there was a valid ingoing value, there is a valid outgoing value for both pointer of both pointies. But in case here, you want two user inputs, age and GPA. GPA is passed by pointer. In this case, incoming value is inconsequential. Notice that we didn't even actually give a value here. Okay, we simply passed its address, but outgoing value is a good value. So in that case, there is an outgoing value. So you should always, when you pass pointer, always put down this comment: is ingoing value consequential? Not, then outgoing will always be consequential. So outgoing will always be true. In swap, ingoing and outgoing, both are important, both are consequential. Okay, so this is video number 6 on user-defined functions in C language. I have one more video to go, and then I'm done with the topic of functions. Number 7 will be that even though you're passing by pointer, and we showed in earlier video, you can pass large blocks of memory using pointer. But since function has power to mutate that value, sometime we want to prevent that mutation. That will be the last video in this series. Thank you. Enjoy.